welcome back to school. I hope you all had a great Christmas break. I'm sure you're excited to be back at school and are even more excited to be learning new math. Yes, this semester will have even more fun than last semester. And to let you know how much fun I'm having right now, it is 7:50 on December 26th. This room is 59 degrees. I'm standing here in 3 layers of clothing, a coat, and 1 mitten, trying to record this lesson for you. So I hope you all enjoy. I hope the cool blue screen will help you think about a nice, cool room right now. Hopefully, you have been given your new assignment sheets. If you'll recall, you are doing just 1 day of new material today. It goes with the material we were doing before Christmas on polynomials. Your journal that you had before Christmas, it is the one you should still be filling in. It is due next class. Also next class, you will be having a big quiz on the material you learned today, so you should come prepared for that. And now, on with the fun excitement of function operations. As you can see here, I already have the material partially created for you. You'll remember we talked before about having functions. We called them f of x and g of x. And of course, you'll recall that if I ask you to find f of -2, that simply means that you should take -2 and put it in for every x in function f. Function f is the top function, so I'm putting -2 in place of each of the x's, and then I'm simply going to work out the answer. -2 squared is +4 plus -6 plus 2, and if we add that up, it actually turns out to be 0. If you recall, what that really means in terms of a graph is that you just put -2 in for x, and you just found out that y is 0. What we're going to do, though, is we are going to be combining 2 different functions together today. So you'll notice the first one I've asked you to do is what's called f plus g of x. That's simply exactly what it says. It wants you to find function f plus function g. Now, the parenthesis x on the end, that is not times x. That's the same thing as saying f of x. This is f plus g of x. That x is there for you to substitute a number into if needed. So since this one asks you to find f plus g of x, it simply wants us to come up with a formula for a new function that still has x's in it. We aren't going to put numbers in this one. So all you need to do is add functions f and g together. Now up here above, you will see that they're lined up perfectly, that we actually could add these together very easily right now by simply adding down. So if I add x squared plus 3x squared, I'll have 4x squared. 3x minus x is plus 2x. And then +2 plus 7 more is going to make +9. And you have created a new function, the function f plus g of x. Whatever you do, don't times by that x at the end. It's f plus g of x, not times x. The second one is that we're supposed to find g minus f of x. So we are simply going to take function g and subtract function f. Now this one I will need to write out so that I can be careful to get all my signs done correctly. So I am writing out function g. I am subtracting function f. Now, why am I bothering to write these in parentheses? If you remember, before Christmas, the polynomials we worked with, we wrote them in parentheses to show we were subtracting them. So in this case, what do I need to do with that subtraction sign? And I know you're all screaming, distribute it, and yes, that would be the case. So we are going to change the subtraction to a plus, and then we're going to change all the signs on function f there at the end. Now we're simply adding our 2 functions together. If I combine like terms, 3x squared minus x squared is going to be 2x squared. Negative x minus 3x is negative 4x. +7 minus 2 is going to be a +5. And there you have our new function we have created by subtracting g minus f. Once again, it was g minus f of x, so that means our answer should have x's in it. Now, if they had asked you to find g minus f of 3, you would take the new function we just found, and you would now put 3 in it to see what you get. It doesn't mean take it times 3, it means put 3 into the function. So in this case, 9 times 2 would be 18, minus 12 plus 5. If you add that up, we would get 11. So if they asked you to do a function minus a function of a number, you would subtract the two functions first and then put the number in. Okay, we are ready to move on, though, to our next screen here. We're going to make things a little more exciting. Suppose I ask you to take f times g of x. Well, it's exactly what you think. I need to multiply those two functions together. And this takes us back to our polynomial work we did right before Christmas. I'm going to need to multiply these two functions together. Now, how do I take a binomial times a trinomial? And yes, you'll recall, it's simply distributing. I take 3x times all 3, and then I go back and I take positive 2 times all 3 terms. And I add up the like terms. So if I do that, 3x times everything will give me 3x cubed minus 6x squared plus 12x. And then if I go back and take every term times 2, I will have 2x squared minus 4x plus 8. I should surely have some like terms I can combine, and indeed I do. So I will add up my like terms, but there's only one x cubed term, so I'll start with 3x cubed. If I add my x squareds together, I'll have a minus 4x squared. My x's will make 8x, and then I'll have a plus 8 on the end. And ta-da, you have our new function, once again, we created by multiplying functions together. So it's as simple as our normal arithmetic we did with functions and polynomials before. Now, when it gets a little more exciting, however, is what we're ready for next, when we want to do composition of functions. Composition of functions has a little more pizzazz to it. When you do a composition of functions, what you're trying to do is you're actually putting one function inside the other. That's important. You realize you're putting one inside the other. There are two notations for this, and you have to learn how to use both notations because they're both fairly commonly used. The first one I have here on the left is the one that visually helps you see what you're supposed to do. If you forget that that f is in front, if I just said do g of 2, hopefully you all would go, oh, yeah, no big deal, put 2 into function g. Well, in this case, what that's saying is, yeah, put 2 into function g, but then once you get that answer, take that answer and put it, whatever the answer is, into function f. So you start from the back and you always work your way forward. Put 2 into g, get the answer, then put g into f. Now we are going to use the same two functions we had up above here. So I'm going to put, first of all, I'm going to put g into 2, or 2 into g, and go, okay, function g up there, that would be, I have 2 squared minus 2 times 2 plus 4. And all you mental mathematicians out there have this one worked out immediately and know that we're going to get 4 as a result. Okay, I'm now going to take that answer, and I'm supposed to put that answer where? And of course everybody said, yes, put it into function f. So now I'm taking f, and I'm going to put my answer I just got into it. So we're going to take the 4 we got out here as an answer, and we are now going to put it into function f and work that one out. So if I put 4 into function f is pretty simple. I'll have 3 times 4 plus 2, and and I will work that out and come up with a grand total of 14. And so I do indeed have a final result of 14 when I have put one function into another. As you can see here on the right, I have the same thing written out. I have f of g of 2, and you'll see I have this other notation over here. It looks like it spells fog. It is not fog. That open circle stands also for the word of. So when you see that little round circle in the middle, that means of. And so that is also another way to write f of g of 2. That is exactly the same problem as the one we just worked. When you see that notation, you start at the back, you put 2 into g, get your answer, and put that into f. You always work from back to front. Now this is normally not a major big deal to do when we're putting numbers in our functions. When it gets exciting is when we're putting variables into our functions. We're working with x's instead of numbers. So if we kick over to the next screen, you'll see that I have a lovely set of different functions up here for us. And we are going to try putting several into each other. Now, since I can't let my recording go over 15 minutes and be able to post it to YouTube, now is actually a good time for me to pause before we get started on these, and then you can start part 2.